Hello everyone, welcome to my YouTube channel. In this week video, I'm going to explain to you how you should answer quiz question for chapter 1. So let's get started. Question number 1. A chemist collected samples with 5 data points. The mean and the standard error for the data was found to be 24.752 and 0.9121 respectively. Determine the confidence level of measurement with 99% confidence limit. Alright, so in order for you to answer this question, the first thing that you need to calculate is the standard error. Alright now, so when you want to calculate your standard error, the formula is standard deviation divided by the square root of n. So given to you in the question, your standard error is 0.9121. So 0.9121 is equivalent to your standard deviation divided by your square root of n. So what is n? Is the data point. So given in the question, your data point is a 5 data point. Therefore, your standard deviation is equivalent to 0.9121 times the square root of 5. Therefore, you should get your S is equivalent to 2.0395. Alright, so right after this, then only we can calculate the confidence level. Alright, next up, how we're going to calculate the confidence level is by using the formula. Confidence level is equivalent to plus minus T standard deviation divided by square root of n. Right? So your confidence level is the thing that you want to calculate. So positive, negative T, this is what we are going to find from the table. And then your standard deviation is from the calculation, which is 2.0395. So divided by square root of n, so your n is 5. So how are we going to find what is the value of your T here? So you have 5 data points and then you want it to be 99 confidence limit. So remember here is n minus 1. So 5 minus 1 is 4 and then you want to get it at 99%. Therefore, your plus minus T will be equivalent to 4.604 times your standard deviation 2.0395 divided by the square root of 5. So you will get your confidence level should be equivalent to 4.193993. Right, so how are you going to write the confidence level? So you should write it. Confidence level is equivalent to your mean, which is 24.752 plus minus the value that you get here, which is 4.1993. And then you need to write the statement with 99% confidence limit. Okay, so this is how you should write your answer for question number 1. Let's move on to question number 2. The analysis of drinking water for arsenic yielded values as such written in this question. One of the findings appears to be anomalous. Distinguish if these values should be rejected at 99% confidence level given that the G critical is 2.659. So the first thing that you need to do is you need to be able to calculate what is the mean of this data. So mean is equivalent to the summation of data point divided by the number of data points. So for this case, the number of data point is 14. So basically, I've already calculated this and we get our mean is equivalent to 7.5857. So this is the mean value. And then what you need to do is for each data point, you need to minus with the value of mean, and then you're going to do to the power of 2, right? So after you have done that for all the data, you can be able to find what is the standard deviation. So the standard deviation should be equivalent to the value, the summation of the value just now. So 3.1371 divided by the number of data point minus 1. So your standard deviation is equivalent to the square root of 0.2414. Therefore, your standard deviation is equivalent to 0.4912. Alright, the next thing that we need to check is what type of calculation that we can use to distinguish these outliers. So in the question you were given the G critical, means that you need to do the G test. So in the G test, the formula is your outlier minus the mean. Remember, there's modulus over here, divided by the standard deviation. So first and foremost, you need to find what is your outliers. So what is an outliers is the number that is not close to any other numbers that appears to be in the data point. So in this question, 5.9 is apparently the outliers. So we can write 5.9 as the outliers. Minus the mean, you have calculated the mean, which is 7.5857. So you need to do a modulus there. And then your standard deviation is 0.4912. So your G test should be equivalent to 1.6857 divided by 0.4912. Therefore, your G test is equivalent to 3.4318. Alright, up next, what you need to do is you need to compare. So given in the question, your G critical. So your G critical is equivalent to 2.659. And then you already calculated your G test. So in this question, you found that your G test is actually bigger as compared to your G critical. So since your G test is bigger than your G critical, therefore you need to remove the outliers. So this is the final answer for the second question. Alright, let's move on to the next question. In a reaction between zinc sulfate and oxygen gas, the typical yield is 86.78%. How much SO2 should be expected if 4,897 grams of zinc sulfate are used, given that the molar mass of the zinc, sulfur, and oxygen are 65.4, 32.06, and 16 grams per mole, respectively. Alright, so the first thing that you need to do in order for you to answer this question is to write a balance equation of the reaction. So the reaction is between zinc sulfate and oxygen gas, which will produce the zinc oxide and sulfur dioxide. Alright, so given in the question is the molar mass of each material. So you can know the molar mass of the zinc sulfate is equivalent to 65.4 plus your sulfur is 32.06. Therefore, the molar mass of the zinc sulfate is 97.46 gram per mole. Alright, so in other words, we can say that 97.46 gram per mole is 1 mole of zinc sulfate. Therefore, because in the question it's stated here that you have this much zinc sulfate, so 4,897 gram of zinc sulfate is actually how many mole? So 1 over 97.46 times 4897. Therefore, you should get 50.2463 mole of zinc sulfate. Okay, this is the first part of the calculation. Alright, so now let's look at the equation again. So from the equation, we know that 1 mole of zinc sulfate will produce 1 mole of sulfur dioxide. So from here, right? So 1 mole of zinc sulfate will produce 1 mole of sulfur dioxide. Therefore, since you have 50.2463 mole of zinc sulfate, so basically how much sulfur dioxide that is going to be produced is actually the same. So it's going to be 50.2463 mole of sulfur dioxide as well, because the ratio is 1:1. Alright, now since we know what is the number of mole for sulfur dioxide, what we are going to do is we need to calculate what is the molar mass of sulfur dioxide so that we know what is the yield. So the molar mass for sulfur dioxide is the same concept. So your sulfur is 32.06. So you need to plus, oxygen is 16, but since you have 2 around here, so 16 times 2. So you should get the molar mass of sulfur dioxide equivalent to 64.06 gram per mole. So this is the molar mass of the sulfur dioxide. So in other words, we can say that for 1 mole of sulfur dioxide, the mass should be 64.06 gram. Therefore, because we have this much mole, so you have 50.2463 mole of sulfur dioxide. So you should be having 64.06 times this value, 50.2463. Therefore, you should get 3,218.7780 gram of sulfur dioxide being produced. Alright, so what else is given to you in the question is that the typical yield is this one, 86.78%. Therefore, you need to remember how to calculate the yield. So, actual yield, so you need to divide by theoretical yield times 100%. So this one should be equivalent to, in the question, 86.78%. So basically, the one that you have calculated just now, this one, is your theoretical yield. So you need to find what is the actual yield. So should be expected, means that they want you to calculate the expected yield. So from the previous calculation, we know that the mass of your SO2 is equivalent to 3,218.7780 gram. So, and then they say that the percentage yield is 86.78%. So you were asked to calculate what is the expected yield. So expected yield is equivalent to the actual yield. So actual yield divided by the theoretical yield, which is this one. So the theoretical yield is 3218.7780 times 100% should be equivalent to this one, 86.78%. Therefore, you should be able to calculate the actual yield is equivalent to this value, 86.78 times 3218.7780 divided by 100. Therefore, your actual yield should be 2793.2555 gram. So this is the final answer for this question. Right now, we are at the final question for this week video. A chemist used a 0.150 mole per decimeter cube solution of sodium hydroxide for titration with ethanoic acid. Calculate the mass of sodium hydroxide in 45 centimeter cube of this solution, given that the molar mass of sodium, oxygen, hydrogen are 23, 16, and 1 gram per mole respectively. Right, so the first thing that you need to understand is 0.150 mole per decimeter cube is actually equivalent to 0.150 mole per liter. So from here you need to convert back. So in a way we can write 0.150 molar is equivalent to mole per liter, right? So here it states that it is 45 centimeter cube, right? So if it's 45 centimeter cube, you need to convert into liter. So we can write 0.150 molar is equivalent to the number of mole divided by this one, 45 centimeter cube. You want to convert it to liters, so you divide that into 1000. Therefore, you will get your number of mole is equivalent to 0.150 times 45 divided by 1000. Therefore, the number of mole of your sodium hydroxide is actually 6.75 times 10 to the power of negative 3 mole. This is the number of mole for your sodium hydroxide. Alright, moving on. But the question asks you to calculate the mass of sodium hydroxide. So since you already know what is the number of mole of sodium hydroxide, therefore you can say that number of mole is equivalent to mass over RMM. You already know the number of mole is 6.75 times 10 to the power of negative 3 mole. And the mass is what you want to calculate. You were asked to calculate the mass. So the RMM for NaOH given to you is the molar mass of sodium, which is 23 plus OH. So your O is 16 plus your H is 1. So the mass is equivalent to 6.75 times 10 to the power of negative 3. Then you need to add 23 plus 16 plus 1, which is 40. Therefore, the mass that you should get is 0.27 gram of sodium hydroxide. So this is a rather simple question, and this is the final answer for the last question that we are going to discuss in this week video. Alright, so we have come to the end of this week video. Thank you very much for watching this video from beginning to the end. So I hope this video will help you to understand more on the chapter. So I'll see you again next week. Take care and stay safe. Goodbye.